As we are moving towards a greener, better world, knowingly or unknowingly, the world of aviation is also headed that way. The modern planes compared to older versions are becoming more and more fuel efficient, thus reducing the carbon footprint day by day. The global aviation is responsible for around 2.1% of all human-induced carbon dioxide or CO2 emissions. Due to this, the International Civil Aviation Organization has set a target to achieve net zero carbon emissions by the year 2050. But is it possible to achieve net zero carbon emissions for this huge industry? In 2008, Boeing flew the world's first hydrogen-powered plane from an airfield near Madrid, Spain, a single-seater vehicle to prove the technology was possible. In this video, we will take a quick and of course efficient look at hydrogen energy and its applicability in our industry. Why hydrogen? Despite its challenging extraction, hydrogen is the most abundant element in our universe, the only byproduct being water. This makes it perfect for an alternative fuel for airliners. Long touted as a sustainable fuel, hydrogen is now gaining traction as a viable option for aviation, with tests already underway to demonstrate its efficacy. Hydrogen planes would look similar to traditional planes, albeit with a slightly longer length required. Propellers would most likely be used in smaller planes, with hydrogen-powered fuel cells providing electric propulsion to turn the propellers. Larger aircraft could use hydrogen to power their jet engines. Hydrogen also can be used to create e-fuels, which are generated exclusively through renewable energy, resulting in net zero greenhouse gas emissions. The hydrogen-powered aviation report released on June 22nd stated that hydrogen could be used to power a commercial passenger aircraft for up to 3,000 kilometers by 2035. A medium-range flight of up to 7,000 kilometers should be possible by 2040 or later, leaving only long-distance flights for traditional aviation. By 2035, it should be possible for short-range flight plane, said Dr. Bart Bubeck, Executive Director of the Fuel Cells and Hydrogen Joint Undertaking, a European public-private partnership to accelerate the market introduction of these technologies, which jointly commissioned the report. That means on European soil, you could connect all the big cities in Europe using hydrogen-powered planes. By 2050, the ambitious scenario is that 40% of the European aviation fleet would be powered by hydrogen. A variety of factors will be required to achieve these objectives. To begin with, hydrogen storage technologies must advance in order to carry enough liquid hydrogen in planes for these journeys. New methods of transporting hydrogen to airports will be required in order for planes to be refueled on runways. Interior redesigns will also be required to figure out how to integrate all of the necessary systems and tubing to run commercial planes on hydrogen. With integration, nothing has been done yet on a big plane, said Dr. Bubeck. That'll be a big challenge, and we'll still need to prepare a lot of standards, codes, and regulations. For example, what would be the requirement for hydrogen tanks testing for aviation? Still, a lot of this research has not been done. However, progress has been made in developing the underlying technology of hydrogen planes. Boeing flew the world's first hydrogen-powered plane from an airfield near Madrid, Spain in 2008, proving the technology was feasible. In 2016, the German Aeronautical Research Agency or DLR, the University of Ulm, and a company called H2Fly launched the first four-seater hydrogen plane from Stuttgart Airport. A hydrogen-powered aircraft will need to have four major components: a storage system to safely store liquid hydrogen, fuel cells to convert hydrogen to electricity, a device to control the power of the cells, and then a motor to run a propeller. But is it the most feasible option? The majority of the world's hydrogen is now produced by reforming methane from natural gas, a fossil fuel that emits carbon dioxide. Efforts are being made, however, to develop green hydrogen by converting water into oxygen and hydrogen using an electric current generated from a renewable source, thereby reducing emissions in its production. If this is possible and there are no emissions from the planes themselves, aviation could become a truly green mode of transportation. For now, the price of hydrogen is significantly higher than jet fuel, but as the world of transport starts to adapt hydrogen, the price is, of course, projected to settle down. Of course, in order to achieve the net zero target by 2050, It is the responsibility of the manufacturers, regulators, airlines, and airports as well. Europe appears to be playing a significant role in this, as it's leading the development of many hydrogen-powered technologies, including hydrogen planes. It's possible that your next flight from Paris to Madrid or Munich to Rome will be on a green, clean flying machine that emits no emissions and has no impact on climate change. An exciting glimpse into our decarbonized future.